Hello and welcome to lesson number 6 of this semester. Welcome to Reignite Hope. So thanks for tuning in to watch the video. If you don't have your notebook, pause real quick if you would, go grab your notebook. And we're on lesson number 6. Going to talk about a few new things here today. And I want to start off talking a little bit more about the welding symbol that we started talking about last week. And you might remember we had the basic 3 parts. We had our reference line, we've got our tail, and we've got the arrow. And last week we learned some of the symbols. They're on page 36 at the bottom of your notebook. And we learned the symbol there for a fillet weld. And we also learned the symbol there for a square groove weld. And we also, at the top of page 36, sometimes there's a little circle there. That means they want something to be welded all the way around, okay? And then finally we learned one other thing, this little flag, which means a field weld, which that means they're going to ask you to take whatever it is you're going to weld and do it out in the field. You're going to go and weld something onto a wall or a gate or a fence or something out in the field. So today we want to add a couple more symbols there that again you'll see at the bottom of page 36. And one of those would be this symbol here, which is the symbol for a V groove, and it looks just like a V. So if I had a piece of metal like this and another piece of metal like that, you can see that it forms a V groove, and that's the symbol for it right there. And of course you'd come in here and start laying your beads in there on top of that. Okay, that's the V groove. The other one is kind of like it but a little different, and it's a bevel groove weld. And that's where one side is straight in the symbol and then the other side veers off, and that would look like this, where we've got one piece of metal that's straight on one side and then the other side has a bevel on it. That would be the bevel groove weld there. So V groove and bevel groove. I've written all of these, you'll notice, on the top of the reference line, which you'll remember that's talking about what you're going to do on the other side of the weld joint from where the arrow's pointing. If, for example, we've got our T-joint here, all this stuff here would be talking about what we're doing over here on the other side from where the arrow's pointing. Anything we wrote below would be talking about where the arrow's pointing. Now obviously a square groove and a V groove and a bevel groove won't apply to a T-joint. Most likely it could, but we won't go into that. But for the most part you'd be doing a fillet weld most of the time on your T-joint. So some new symbols there. We're going to learn some more next week. And we'll start talking about a few other things that can get put on the reference line. But for now, try to learn those, and we'll go over it again real quickly when we get here to class. Okay, now for the next topic on lesson number 6, we're going to talk about metals and how to identify them, some of the terminology that gets associated with that, because after all, we're welders. And so we're going to be welding metal. And so there's lots of different kinds of metal. I'm going to talk about the 3 that you're most likely going to start off welding in your career. We're going to talk about steel, stainless steel, and aluminum. There's, of course, titanium and magnesium and cast iron and copper and all kinds of other metals. But for the most part, you're going to start off welding these 3 here, particularly the steel and the aluminum. So I've got a bunch of different pieces of metal here in front of me, and I'll be showing you that and talking about it. But the first thing we're going to talk about is steel. And so steel is something you've been welding back in the shop. Most of you have been doing the steel. We've also been TIG welding some of the aluminum back there. But steel comes in a few varieties. And one of them is just regular old plain steel that will commonly be called mild steel. When you hear the term mild steel, just think regular old ordinary steel. It also can be called low carbon steel because it doesn't have a lot of carbon in it compared to high carbon steels. That makes sense, right? There's a word called alloys that we talk about a lot too when it comes to metals. An alloy just means mixture is all it means. Every metal that you're going to touch isn't going to be pure anything. It's going to be a mixture. For example, here's a piece of aluminum tubing, rectangular tubing, but this isn't pure aluminum. It's got all kinds of other chemicals in it to give it the properties that the manufacturer wanted to have. Do they want it to be harder? Do they want it to be softer? Do they want it to be able to bend? Do they want it to be brittle? All different things they can do to kind of make a recipe or an alloy when it comes to making a metal. So again, an alloy is just a mixture, and they put lots of other things in here to create the final product, just like you would in your kitchen at home, baking a cake. It's got lots of different things in there. So with steel, they can put a low amount of carbon in it, they can put a high amount of carbon in it, they can add magnesium, they can add manganese, they can add chromium, sulfur, all kinds of things to give it particular qualities that they want it to have. And mild steel comes in a couple real common varieties that we're going to talk about. You're going to hear as welders a lot of this terminology, hot rolled versus cold rolled. So here in my hand I've got a piece of steel, and it's got this dark gray coating on it. So this is going to be what we're going to call hot rolled steel. And that comes from the fact that when they produce this at the steel mill, this gets rolled out in sheets at a very high temperature, is why it's called hot rolled, and it forms this mill scale on there, mill scale. It's the scale that developed at the mill, at the steel mill. And so that coating is on there versus a cold rolled steel, which is formed at lower temperatures. That's why it's called cold rolled. And you can see it's nice and shiny, like this piece of square steel tubing here. Doesn't have that dark gray mill scale coating on it. Both of these would be considered in the mild steel category as well, but keep in mind the difference between the mild or the hot rolled steel and the cold rolled steel. Cold rolled's nice in that you don't have to do anything much to prep it. Just clean it up with some simple green or some alcohol or acetone or something, and you're ready to weld. Whereas ideally, if you're welding mill scale, the best thing to do is to grind off that gray mill scale coating and get down to the bare, shiny metal that you see there. Now, stick welding and MIG welding and flux core welding are pretty forgiving when it comes to just welding right over the top of the mill scale. TIG welding would not be. You would need to grind the mill scale off of there. Cold rolled, as nice as it is, you might think, well, why don't we just buy cold rolled all the time? Well, it's about 3 times more expensive, that's why. So hot roll gets used a lot out there in the industry. So again, all of these are mild steels. 2 distinctions here between hot rolled steel and cold rolled steel. Some questions on your quizzes in the future will be true or false, hot rolled steel has a mill scale coating. The answer is true. It has mill scale. Cold rolled steel does not have a mill scale coating. Now, a second kind of metal would be in the steel family still, but now it's called stainless steel. You've seen maybe sinks in your home that are stainless steel and they don't rust even though they're exposed to water all the time. Or in restaurants, in kitchens, a lot of stainless steel gets used, or sometimes steel railings that are outdoors are made out of stainless steel so it can stand up to the weather and not rust. And so here I've got a piece of stainless steel in my hand here, and kind of almost looks like aluminum, but it isn't. It's heavier than aluminum is. Steel weighs about 3 times as much as aluminum does. So aluminum is real popular in applications where you're trying to save some weight. But this is stainless here. And what makes it stainless? Well, again, we go back to our word alloy, the mixture. They can add chromium into the mixture there. And the chromium gives it that ability to not rust and to remain stainless. So it would have chromium in it to give it that quality there. Another difference between stainless steel and regular steel is that here's the regular steel again, magnetic obviously. Stainless steel, not magnetic. Now there are some alloys of stainless steel that are magnetic, but most of the ones you're going to encounter are not magnetic at all. Again, versus regular steel, which is quite magnetic. Aluminum, on the other hand, also not magnetic either. And you know, they look a little different, but they're not tremendously different, okay? But again, the steel would be heavier and generally speaking much harder than the aluminum would be. And lastly, I just want to talk about aluminum for a few minutes here. Aluminum comes again in a bunch of different alloys. Most of what you've been doing back there, TIG welding, is the alloy 6061. And so we've been using that back there a lot in our booths, but there's 5052, 4043, all kinds of different alloys that get used. And again, they have different tensile strength and a little bit different properties to them. But again, aluminum is nice. It's expensive, more expensive than steel, but it weighs 1/3. So something you would build out of aluminum that weighs 3 pounds, that very same thing would weigh 9 pounds if you built it out of steel. And I want to talk a little bit also now just a little bit about the shapes of metals. So obviously we can have metals just come in plate, flat plate like the stainless here and like the aluminum here, flat plate. It can come in all different kinds of tubing. Here again we've got some aluminum rectangular tubing here. We've got some square tubing here, and steel comes in all of this too. So everything I'm saying right now about the aluminum is true of steel and stainless steel. Square tubing. Here we've got a small piece of round tubing here of aluminum. We could even have solid bar. So we call this solid bar. This is aluminum, not very heavy given how big it is, but again, because aluminum's so light. Solid bar aluminum, and that could be steel as well. Here's a piece of angle iron, again formed at an angle there, actually a 90-degree angle. Hot rolled again, look at the dark gray mill scale coating on there, hot rolled steel and in the form of a 90-degree angle. And when these things get measured, for example, or you go to buy them, if you were to buy this, for example, there's 2 dimensions you need to know, the width of your metal and the thickness of it. So you'd say, well, I want 1¼ inch square tube aluminum 1/8 inch wall. That's what you would order if you wanted a piece of this. Here again, now you're going to have an extra dimension. You've got the width, you've got the height, and you've got your wall thickness again. This is also 1/8 inch thick. And I don't know, maybe that's 3 inches by 1¼ inch, something like that would be how that gets measured. When we start talking about tubing, either aluminum or steel, we're going to talk about the diameter of the tubing. So this is maybe 1/2 inch diameter aluminum tubing, and it looks like it's probably got about a 1/16 inch wall thickness. So wall thickness and diameter is the dimensions that we'd need to know. And now with our solid bar, we're only going to be interested in diameter. There's no wall thickness, it's solid. So I don't know, 1¼ inch on this too maybe as well. And then our angle iron, a couple things there. We have the width of our angle iron and the thickness of it. So maybe we've got something here like 1½ inch by 1/4 inch thick angle iron. Again, hot rolled gray mill scale versus cold rolled steel. And again, that's a variety there of steel, stainless steel, and aluminum. So you'll get more and more familiar with that all the time. Really try to keep in mind the hot rolled versus the cold rolled steel. Okay, that's a big one, all right? And we'll talk more about this in class this week, okay? Thank you.